the number on the right and divide it by the number that precedes it, right before it. So 16 over 48. So if we reduce that, um, you can start dividing it by a number to reduce it down. So they're both divisible by 8. They're both divisible by 16, actually. Now, if you don't notice that they're divisible by 16, you could divide them both by 2 and keep going, but that's going to be 1/3. So we're multiplying by 1/3. I would prefer you say it that way. You will be okay if you say dividing by 3, but I would prefer that. Multiply by 1/3. So all you have to do is multiply that last number by 1/3. So 16 over 9 times 1/3, when you multiply fractions, you multiply straight across. So that's going to be 16 over 27. All right. Now, what's going on here? So you're looking, the numbers are getting bigger. Maybe you try addition. So that would be plus 12. Okay. You could look here and say, well, what's happening to that? That is 24. And then that is 48. So we're doubling the amount we're adding each time. So if you think about doubling, if we doubled that list, that would be 11, and then it would be 22. So if we doubled it, it would be 22, but it's not 22, it's 23. So if we add 1, that would be 23. And if we double 23, we would get 46. But we would need to add 1, it would be 47. If we double 47, we get 94, but we would have to add 1. So the pattern is double and add 1 would be one way you could say that. There are other ways. Multiply by 2 and add 1. All right. And again, I haven't been saying pause every time. I'm not going to probably say pause every time, but really you should try to pause and do each question. Coming back here, I should have said this is a geometric sequence, geometric list of numbers, and geometric is when you multiply or divide by the same number over and over again. Then you get a geometric sequence. Okay, moving on to inductive reasoning. So inductive reasoning, so big part of the lesson was patterns, and now we're going to talk about inductive reasoning. Okay, so in inductive reasoning, you look for a pattern, and in the past that has shown up on some different tests. So really what you want to memorize is inductive means that there's a pattern. That's what you want to focus on. Okay? So, if they're asking you about inductive reasoning, you're trying to see if there's a pattern or not. Make a conjecture. Oh, to use inductive reasoning, look for a pattern. Make a conjecture. A conjecture is an unproven statement based on observations. Okay, so example 3, the product. So first of all, you need to, math has some vocabulary, and you need to know what product means. So you need to think about what's the definition of product. So a product is an answer to a multiplication problem. Of any two consecutive means one after another. So we can express that with variables. We could say n, and then if you can pause the video and think about what would be an expression for a consecutive number after n, it would be the next number after n, that would be n plus 1. Positive integer. So we need to think about what are integers. So hopefully maybe you remember what integers are. Integers are the whole numbers and their opposites. So that would be -3, -2, -1, 0, 1, 2, 3, and on and on and on. So that's what integers are. Now, I just said whole numbers and their opposites, so that means you should know what whole numbers are also. Okay. So whole numbers start with that first number that has a hole in it, 0, and then 1, 2, 3, etc. And then one more type of numbers while we're here, the natural numbers. And some people call them the counting numbers, and they would be the most basic kind of numbers you would ever think of. And when you're a little kid, the first numbers you learn about is how to count. And you learn 1, 2, 3. So whole numbers just adds 0, and integers adds the opposite of the natural numbers. Okay, so the product of any two consecutive positive integers is what? So we want to use inductive reasoning to figure that out. So pick two consecutive positive integers, so 2 and 3. You could pick any you wanted. I'm going to pick smaller numbers so I don't have to work it out as much. So 2 times 3 is 6. We could just go in order, so 3 times 4 is 12. 4 times 5 is 20. So we want to make a conjecture about all of these numbers. Every time we multiply two consecutive positive integers together, what do we get? What's something that all of these numbers have in common? Okay, you can pause if you want to. The answer is they're all even, and maybe there's something else, but that's what we're going to go with. That's all I can think of at the moment. Okay, a counterexample. A counterexample proves that a conjecture is false. It just takes one counterexample to prove something's false. You could have a bunch of examples of something. That doesn't prove something's true. It gives you an idea that it might be true, but it doesn't prove that it's true. But if you can show one thing so that something doesn't work, then you have a counterexample and you've proved that it doesn't work. Okay, so the difference of two positive numbers is always positive. The difference of two positive numbers is always positive. Okay, so when you're doing this, you want to think about a few things. You want to try different types of numbers. That's one thing you want to think of while you're trying to come up with a counterexample, is don't always pick the same. And when we talk about different kinds of numbers, you talk about positive, negative, 0. You could think about rational numbers. So there's another number type, rational numbers. Rational numbers have a ratio in them, which means basically that you can make a fraction out of them. So 2 is a rational number because you can write 2 over 1. 2 over 1 is a fraction, even though most of us would have just reduced that to 2. Okay, so